Hey, happy Monday. Sorry I can't be with you guys today. I'm home with sick kids, but hopefully you had a good weekend. We are going to continue forward here with our lessons. And so today we are going to go through 2.1.5. And I think today should be a little bit easier than what we've been doing to end last week, but still kind of along those same lines. And I think today's lesson should be a little bit shorter, a little bit less work, hopefully for you. And so please turn in your note packets to 2.1.5. How can I model the data? So today, what we are looking at is how to go from a situation to an equation. And today, what we are really focusing on is being able to find the a value in our equation, which we'll talk about here in just a little bit. Okay, so it says, in the past few lessons, you have determined how to move graphs of parabolas around, that is, how to transform them on a set of axes. Now, you have also learned how to write quadratic equations in graphing and in standard form. And that's what we did towards the end of last week, which was no joke, right? And so in this lesson, we will put these new skills to work to use parabolas and their equations to model situations. So our first one here, okay, is 2-64. It says, for jumping jackrabbits, the diagram at the right, which is down here, okay, we see a jackrabbit jumping over a 3-foot high fence. To just clear the fence, the rabbit must start its jump at a point 4 feet from the fence. Okay, so we're going to sketch the situation, write an equation that models the path of the jackrabbit, know how to explain how you know your sketch and equation fit the situation. So take a few minutes, pause the video here, take about 5 minutes, work with your team, see if you can work through these discussion points that ask, how can we make a graph fit this situation? What information do we need in order to find an equation? And how can we be sure what our equation fits the situation? So take about 5 minutes, work through this, and then I'll come back here in just a second. So pause the video here. So as we look here at this jackrabbit, and I'm going to kind of jump down to 65 here, which we really start to work with our equation. Okay, so it says sketch the path of the jackrabbit on your paper. Choose where to place the x and y axis in your diagram so that we can do the problem easier. So if I look back here on 64, which is a question hopefully you just answered, okay, I know that my a value is going to be negative, okay, because my parabola is looking like this, right? That's the jump, okay? So it's negative opening down, right? Opening down, okay? I do have a good idea what this vertex is. I know that's 3 feet high, okay? And we'll work through this in a little bit, okay? So right now, as I look at my basic equation, we're going to look in graphing form, okay? I have x minus h squared plus k, okay? And so I know this a is going to be negative because it's opening down, and I know my k is going to be really this kind of plus 3 because I'm going up 3. So that's kind of a good start here for us as far as how we are going to look with these. So in 65, okay, what is the shape of the jackrabbit path? We know this is a parabola, and we want to best use this with that equation. Y equals a times x minus h squared plus k, where we know, again, my vertex is the point hk. And so it says in letter B, what point on your graph can tell you about the values of h and k in the vertex? Find the values of h and k into the general equation. Is your equation finished? Okay, so right now this is about what we have, right? We know our vertex is going to be here, okay, which is going to be some value, and I really should know kind of where this value is because I know that hk is my vertex. I know that the k value is going to be plus 3. So this h value, okay, we know this is a mirrored image. So to go from 8 to 8, the middle of that is going to be 4, right? Because that's then going to be 4 and 4 for a distance of 8 feet, okay? or I can really go 8 divided by 2 equals 4, right? So this is what I have right now. In my equation, I have y equals a times x minus 4 squared plus 3. Because I know my vertex is at the point here 4, 3. Okay? Now, we don't necessarily know exactly where we're starting, but we know this is kind of a good idea of where my vertex should be. So what we are doing is we are missing our a value. So how do we solve this a value? This is really the whole point of what today is going to be about, okay? Is solving a value, okay? So again, we need to kind of pick a point here. We have most of an equation. So if I do this, let's say he is starting at the point 0, 0, okay? We should then be able to solve this pretty quickly because I have x and y. So I'm just plugging in this data. So I have then 0 is equal to a times 0 minus 4 squared plus 3. And again, we're working to solve for a. But now we should be able to do that. I have a negative 4 squared plus 3. It's going to continue on the side here, where 0 is equal to 16a plus 3. We should be able to solve this. Subtract 3, 16a, divide by 16, and a I'm going to leave as a fraction is negative 3 over 16. Again, I know this should be negative, and so we should have a pretty good idea here, okay? As I look at domain and range, okay, my domain is possible x values. Here we're saying our domain really kind of depends on where we are looking at, but we could say like from 0 to 8 are possible x values. Okay, and then my range, again, for this situation, is going to be from 0 to 3. This is the height, right? Where this is my possible y values. Okay? This is like my length. Okay? Or left to right, up and down, which has been a while since we've done domain and range. Okay? I'm going to skip over E here, but we're going to look at another problem here. Okay? So, as I look here, I am looking at 66. Okay? It says, when Miss Bibby kicked a soccer ball, it traveled a horizontal distance of 150 feet and reached a height of 100 feet at its highest point. Sketch the path of the soccer ball and find an equation for the parabola. So I'm going to let you kind of work through this here a little bit on your own. Again, pause the video here, take about 5 minutes or so, and then I will start to go through it here with you. So I think it's easiest to kind of look at this in terms of a graph here to start, okay? So we know the soccer ball started here, it came up, it came down, okay? I know that this length here is 150 feet, okay? From where it went to where it came down, and it hit a height of 100 feet. Now, I don't know much about soccer, but that seems like really a pretty good kick to me. I think that would be better than anything I could do, okay? So, again, we know that this vertex is 75, again, half of 50, 75 and 75. So 150 divided by 2 gets me 75, and a height of 100, okay? So as I look to then come up with my equation, y equals a times x minus 75 squared plus 100. And again, I need to solve this. A little bit bigger numbers here. Pick a point. 0, 0, let's say, is where it's starting. And we don't technically know exactly where it's starting, but it gives us a good idea. And I have 0 is equal to a times 0 minus 75 squared plus 100. Or 0 is equal to a times negative 75 squared plus 100. Or 0 is equal to this is 500 or 5,625a plus 100. Subtract 100 from both sides. I have negative 100 equals 5625. Pause the video if I'm going too fast. Divide by 5625. I'm going to simplify this fraction, which you should be able to do in your calculator. Okay, you get negative 4 over 225. And so then I can write my whole equation. I'm plugging this in for A of negative 4 over 225 times x minus 75 squared plus 100. And that is a pretty good equation of what this is going to look like. Let's do one more here, and then you can start in on your homework, okay? So 67, it says, at the skateboard park, the hot new attraction is the U-dip, a cement structure embedded into the ground. The cross-section view of the U-dip is a parabola that dips 15 feet below the ground. The width at ground level, its widest part, is 40 feet across. Sketch the cross-sectional view of the U-dip and find an equation. So again, pause the video, see what you can do. Again, I think a picture would help with this. Go ahead and get started. So as I look here at this picture, this one's going to be a little bit different, okay? As I look here, this is my X and Y axis, okay? I'm coming down and then back up here. This is a U-dip, okay? I know this is 40 feet, and I know it goes down 15 feet, dips 15 feet below the ground, okay? So this is 15 feet. Okay, and technically, if we're going parabola, this goes on. Okay, now, again, we should be able to have a pretty good idea of what my vertex is. Okay, so my vertex is 20 feet, 20 feet. This one's below ground, so I have 20 feet by negative 15 feet. Okay, that's my vertex. Okay, so again, as I look here, I have A and I have x minus 20 squared. This one's going to be minus 15. And then same idea, pick a point, 0, 0. These situations, these are easy points to pick. I have 0 equals A times 0 minus 20 squared minus 15, or 0 is equal to negative 20 squared A minus 15. This is going to be 400. A minus 15, add 15 to both sides. I know this A should be positive, so I have 15 equals 400A. Divide 400, again, simplify this fraction. Divide both by 5. I get A is 3 over 80. And then again, I can finish by writing out my equation. 3 over 80, x minus 20 squared minus 15. So hopefully this went a little bit smoother and easier for you. Today your homework, and you will have a homework quiz on Wednesday this week of the last 2 weeks' homework, is 2-69, 2-73, 2-74, and 2-75. I am hoping to be back on Wednesday so we can go through any questions that you have, but hopefully you're able to do most of this here on your own. Have a good day.